Hi guys, Amaris here. Today it's about Windows 98 getting a brand new NVMe driver. I know this might sound like old news if you watched my previous videos. In fact, I've already shown Windows 98 running from NVMe drives on modern Intel and AMD systems, most recently on this Ryzen 9 9900X build with a 2TB Gen 5 NVMe SSD from Kingston. But this time things are different. Now we're looking at a proper driver that lets Windows 98 talk directly to an NVMe drive, just like modern operating systems do. This driver was made by Sweetlow and is a port of the NVMe 2K driver created by Dominic Baer, which I recently showcased here on the channel running on Windows NT and 2K. Basically, this is what happens when clean, well-documented code meets a hardcore Windows 98 fan like Sweetlow. He's also the one who made the VXD variant of CrackFix and released many other patches and disk utilities. Now, to really appreciate this driver, let's first look at how things worked up until now. The other way to access an NVMe drive in Windows 9X is by using what Microsoft calls MS-DOS compatibility mode, where the drive is handled directly by the BIOS through its own low-level drivers. The crazy part is that disk access has remained largely unchanged since the early DOS days. And on this AM5 build I'm using right now, even something like MS-DOS 3.3 can work with our disk configuration. Of course, as long as the compatibility support module is enabled and the disks are properly formatted. You don't think that's possible? Just let me take you very quickly back to 1987 when MS-DOS 3.3 was released. It was a very popular DOS version at the time with FAT16 support, and we're going to run it on bare metal on this Ryzen 9 9900X PC with 64 gigs of RAM and 2 NVMe SSDs. To make things more interesting, we're doing it from a USB floppy, which MS-DOS sees as a standard floppy drive. Why? Well, because the BIOS says it is, and DOS doesn't argue. Actually, DOS can't tell the difference because it never talks to the hardware directly. It simply asks the BIOS to read and write disk sectors through the BIOS disk services, better known as INT13H, the same way MS-DOS 3.3 would have done back in 1987, maybe on a 286 PC. And the same principle applies to our SSDs. If the BIOS presents them as regular fixed disks, DOS and later Windows 3X and Windows 9X can use them without knowing what the actual hardware is. So if accessing an NVMe drive through the BIOS actually works in Windows 98, why would anyone bother writing an NVMe driver at all? Well, MS-DOS compatibility mode comes with quite a few limitations. We'll get to those in a minute, and you'll see why writing all that fancy code for a proper NVMe driver really pays off. And speaking of coding and how things work under the hood, here's a quick note from today's sponsor, boot.dev, the place where coding courses are fun, engaging, and focused on the stuff that really matters behind the scenes. So, if dull lectures put you to sleep, boot.dev does things differently, because everything feels less like a classroom and more like an RPG, where you earn XP, level up your character, complete quests, fight bosses, and depending on the course you pick, you'll be writing real code, whether it's Python, Go, SQL, or TypeScript. You know, the kind of stuff companies actually pay real money for. And yeah, we're talking 6 figures, since the average salary for backend developers in the US is well over 100K. They've got also this bear wizard called Boots, who acts as your personal AI tutor, and they recently launched the training grounds where you can overlevel before jumping back into main quests. Best part, everything is free to read and watch. You only pay if you want the full interactive mode with the coding environment, XP, levels, achievements, and all that juicy gamer stuff. So if you want to try it out, head over to boot.dev and use my code OMORES for 25% off your first year. The link and code are in the description, and I've also put a QR code on the screen if that's easier. Now let's get back to why using MS-DOS compatibility mode comes with limitations. First of all, relying on the BIOS to access NVMe drives doesn't always work with Windows 9X. This is mostly because the compatibility support module, or CSM, has different implementations, so results can vary. That's why we may run into Windows protection errors when trying to use an NVMe drive. In my experience, it usually works if the primary partition is kept under 8 GB, since that's the maximum the old CHS standard can address. This is how I used NVMe drives in DOS, Windows 3X, and Windows 9X, at least until this driver came along. Now, when it comes to storage limitations, using this driver means we're only constrained by the FAT32 standard, which limits individual file sizes to 4 GB, but partitions can be as large as 2 TB. In the meantime, the standard formatting tool introduced with Windows NT and still present in Windows 11 was limited to FAT32 partitions not larger than 32 GB. It took about 30 years to finally get an update that removed that limit. Windows 98 formatting tool never had this restriction. And here I am formatting a 512 GB NVMe drive in Windows 98, ending up with a fully functional, roughly 500 GB FAT32 partition. Next, let's talk about speed. Well, accessing an NVMe drive, or really any drive through the BIOS, is simply slow. We're talking about transfer speeds in the range of 5 to 20 megabytes per second, which is obviously incredibly low for an NVMe drive, but still faster than a typical IDE drive from the Windows 98 era. So how fast can an NVMe drive be under Windows 98? First of all, we can't reach the maximum specs of whatever NVMe drive we're using, since there are some limitations introduced at the driver level to keep things stable and reliable within the Windows 9X architecture. With the first version of the driver, Crystal Diskmark reported speeds of about 300 megabytes per second. The same performance we can get from a SATA SSD using Rudolph Lau's AACI driver. The latest version of the driver is much better, and now we can hit a little over 1 GB per second in most benchmarks. That's obviously a crazy amount of speed for Windows 98, and we don't really need that kind of performance, but it's still nice to see that the system stays stable and we can copy a CD image in about 2 seconds and maybe load a Half-Life 2 level a bit faster compared to a SATA drive. So yeah, the driver is definitely stable. It works with various NVMe drives on different configurations, and so far so good. The next question is whether we can actually boot Windows 98 using this NVMe driver. Well, not really. It depends once again on the CSM implementation. During the switch from real mode to protected mode, things don't always behave as expected, and we can end up with a bunch of errors when the driver tries to take over. While testing on this AM5 system with a Ryzen 9 CPU, Windows 98 partially booted, even the video driver loaded, but then it froze, and that was as far as it got. And the same thing happened on an AM4 build with a Ryzen 5 and a B550 motherboard, and also on a B360 system with a Nitrogen Core i5. I'm sure things will get better, but for now, booting from NVMe didn't work on my test systems. Anyway, if we do run into trouble, all we need to do is delete the driver file from Windows/System/IO subsys, and we're back to basic BIOS disk access. As for installation, as mentioned in the README file, there is nothing special about it. It installs just like any other driver. The NVMe drive shows up as an unknown PCI device, and we just need to figure out which one it is and load the driver. Alright, it's time to wrap things up. Next time someone says, but there are no drivers to run Windows 98 on modern hardware, which honestly would be a pretty reasonable assumption, I can't wait to bring up this brand new NVMe driver. And that's not the only good news. I just noticed there is a new HD audio driver for Windows 98. This is not the old 16-bit driver made for Windows 3.1 that I covered before while running Windows 98 on an AMD FX 8350 build. but a brand new and very interesting driver specifically tuned for Windows 98 and Windows Millennium. We'll check it out for sure in a future video. Now, a huge thanks to boot.dev for sponsoring this episode. And if you want to go all in on modern coding, check them out at boot.dev and use code OMORES for 25% off your first year. That's all for today. OMORES out.